We float in an ocean of quiet, a vast, endless dark that we have only just begun to understand. From our tiny blue world, we look out into that deep and we find comfort in its patterns. We map the elegant clockwork dance of the planets. We trace the long, looping paths of comets, those ancient travellers of ice and dust born in the cold darkness beyond Neptune. We have learned the rules of this ocean: gravity, thermodynamics, motion, and then sometimes something comes along that reminds us just how little we truly know. It begins as a whisper, a digital murmur passing between the great telescopes of the world. A new object has been detected crossing the void between the stars, an interstellar visitor. We have seen them before, but this one is different. There is a feeling, a growing shared unease among those who watch the sky. A consensus that forms in quiet chat rooms and late-night data reviews spoken in the cautious language of science. Something is wrong with the comet from another star. The first real clue does not come from Earth. Our own atmosphere, our bright noisy skies they hide so much. No, the first warning comes from our silent robotic scout orbiting Mars. China's Tianwen-1 orbiter, whose primary mission is to map the canyons and dust storms of the red planet, also keeps an eye on the dark. It sends back a packet of data, a series of images. At first, the technicians on the ground assume the files are corrupted. The object designated 3 Atlas is there right where the orbital projection said it would be, but it looks wrong. The images are puzzling. They are blurred in ways that defy optics. There is a shimmering quality, a subtle pulse in its light signature that does not match any known celestial phenomenon. The data is checked, the telemetry is confirmed, the instruments are clean, the images are not corrupted. The object itself is the source of the problem. And then it gets closer. Atlas begins its long fall toward our sun. This is the moment of truth for any comet, the perihelion passage. It is a trial by fire. The savage, unfiltered heat of our star should blast this icy traveller. The ice should turn to gas, the dust should be thrown wide. This is what creates the magnificent, glorious tail of a comet, a plume of debris and light stretching millions of miles, a spectacle visible even to the naked eye. We watch with every instrument we have. We watch as 3i Atlas swings around the sun, enduring temperatures that can melt lead, and we measure its mass before and after. The numbers that come back are staggering. The object lost 13% of its total mass, a truly enormous amount of material. It has been cooked, scoured, and lightened by a staggering degree. 13% of its entire being vaporized and cast out into space. But here is the paradox. Here is the impossible fact that stops every conversation. It had no tail, there was no plume, no gas, no debris field, no magnificent spray of dust, nothing. Where did 13% of a comet go? How can something shed that much of its own body without leaving a single trace? The only thing observers could report was a faint uniform glow, not a coma, not the fuzzy cloud of gas we expect. This was different. It was a sharp, ethereal haze that seemed to cling to the object's surface as if held there by a force that defied the relentless power of the solar wind. This mystery, the tailless comet, becomes the headline. But for the scientists digging into the data, it is only the beginning. They find that this is not the only unusual thing. As observatories around the world compare their findings, the list of problems grows. One anomaly: its trajectory. It isn't a smooth, clean hyperbola. The path shows tiny, almost imperceptible deviations, small adjustments that our models cannot account for. Another anomaly: its temperature. The side facing the sun is far too cold, the side facing away from the sun is too warm. It seems to be actively managing its own heat, defying the basic laws of thermal radiation for a simple piece of ice and rock. Another: its spectrum. That faint glow when broken down shows chemical signatures in ratios that should not exist, elements that we do not find together in nature. The list grows. Its radio silence is unnatural. It seems to be absorbing background radiation. Its rotation is too stable, too perfect. In the end, the Minor Planet Center, the official record keepers of the sky, compiles the data. They list 10 distinct major anomalies, 10 separate ways this object violates our known physics. In science, we deal with probability. We ask, what are the chances? What is the chance that one single natural comet would just happen to have a strange trajectory? Possible. What is the chance it would also have an impossible thermal signature? Unlikely. What is the chance it would also have a bizarre chemical composition and lose 13% of its mass without a tail? They ran the numbers. The probability of a natural object displaying all 10 of these anomalies at the same time is less than 1 in 10,000. This is the moment the universe falls quiet. When faced with odds like that, we must be careful. the most extraordinary claim humanity can possibly make is that we have seen evidence of something other, and extraordinary claims demand extraordinary proof. So let us be clear, we are not saying it is artificial, we are not saying it is a probe or a ship or a message from an intelligence we cannot comprehend. To make that leap is to abandon the very discipline that brought us this far. But we must also be honest, we must see what is not what we wish. We are saying that something very, very strange just passed through our solar system. It did not behave like a comet, it did not behave like an asteroid, it did not behave like anything we have ever seen. It broke the rules. It is now moving away from us, fading back into the interstellar dark, accelerating toward an unknown destination. It has left us with a puzzle that has no easy solution. And as it disappears, it leaves behind a silence that is deeper and heavier and more unsettling than the silence that came before. While we waited on Earth, squinting through the deep, shimmering blue of our atmosphere, humanity's most privileged view was already in deep space. We had an emissary, a robotic explorer already positioned in the front row. It was orbiting another world, Mars. The mission is called Tianwen-1, a name that beautifully translates to Heavenly Quest. For years, it had been dutifully performing its primary mission, studying the red planet. Its powerful cameras were designed to look down to map the ancient riverbeds, the vast dusty plains, and the towering volcanoes of Mars. It was a geological mission, but on October 3rd, 2025, the mission controllers on Earth gave this lonely probe a new, extraordinary and secondary assignment. They asked this complex machine, this extension of our own senses, to pause its Martian duties. They asked it to turn its head. In the silence of the void, Tianwen-1 swiveled its instruments. It turned its gaze away from the familiar red globe below, away from the life-giving sun, and pointed its lens out. It stared into the cold, empty and profound darkness of interplanetary space. It was aiming for a shadow. That Shadow 3E Atlas was a target unlike any other. We knew from our calculations what it was. It was a ghost moving at a speed that is difficult for the human mind to truly grasp. 58 kilometers for every single second that passes. That is over 129,000 miles per hour. A velocity so immense that it is a cosmic fingerprint, a definitive sign that 3i Atlas did not belong to our family of planets. It was a true outsider, a visitor from the interstellar deep. And our data told us its size. We estimated it to be a solid object, perhaps 5.6 kilometers wide, a tumbling dark mountain larger than many of the cities we live in, adrift in the void and briefly, so briefly passing through our neighborhood. Now let us pause and truly consider the task given to this probe. It is one thing to know an object is there, to track its path as a mathematical point. It is another, far more difficult thing to see it. The challenge facing the China National Space Administration, the CNSA, was almost beyond belief. First, there is the simple, crushing problem of distance. When Tianwen-1 aimed its camera, 3i Atlas was almost 30 million kilometers away. That is 18 million miles. That number is so large it almost becomes meaningless. So let us try to imagine it. It is like standing in one city and trying to take a clear photograph of a single unlit building in another city hundreds of miles away. But it's worse than that. The target was not a bright, shiny building. The data suggested, and we now know for certain, that 3i Atlas is one of the darkest objects ever observed. It is darker than fresh asphalt, darker than a lump of coal. It absorbs almost all the precious sunlight that falls on it, reflecting almost nothing back. So you are not trying to photograph a building, you're trying to photograph a single city-sized piece of charcoal in the dead of night, from 18 million miles away. And it's even worse still. Both you, the photographer, and the charcoal are moving. Not just moving, but screaming through space at incomprehensible speeds. The Tianwen-1 orbiter itself is circling Mars at thousands of miles per hour, and 3i Atlas is blazing south past at 129,000 miles per hour. This was the technical gamble to capture a clear image of a city-sized piece of coal 18 million miles away while both of you are moving faster than bullets. The camera on Tianwen-1 is a masterpiece of engineering, but it was built to look at Mars. It was designed to capture sweeping vistas of canyons and plains, a huge, bright planet that was right there filling its view. It was never ever intended to be a long-range interstellar telescope, a sniper's rifle for the cosmos. What the CNSA was attempting was a brilliant act of improvisation, pushing their billion-dollar machine to do something it was never designed to do. And so the probe pointed. It stared into the blackness. It opened its digital eye, and it waited. The faint photons of light, having travelled from the sun, crossed the solar system, bounced off that dark, distant rock, and then travelled another 30 million kilometres. Finally ended their journey on the probe's sensitive sensor. That data, just a handful of signals, was captured, compressed and beamed back to Earth. And then, silence. For a whole month. From October 3rd to November 5th, the world waited. We knew the observation had been attempted, but we did not know if it had succeeded. On Earth, in quiet, brightly lit rooms, scientists and engineers were working. They were processing the data. They were filtering out the cosmic rays, the digital noise from the camera, the faint light of distant background stars. They were stacking image upon image, adding them together, trying to make a ghost visible. On November 5th, 2025, they showed the world what they had found. The images were historic. They were blurry, they were faint, composed of just a few pixels, but they were real. They were by far the clearest, closest, and most definitive images humanity had ever captured of an object from another star system. We could finally see it. Not as a point of light in a telescope, not as a line of code in a computer model, but as a place, a physical object. And in that moment, as the world looked at that faint speck of light, the entire story changed, because the most important part of that photograph was what was missing. We expected a comet. We have seen interstellar comets before. A visitor named Borisov, which flew by in 2019, had a beautiful classic tail. We all assumed 3i Atlas, as it got closer to our sun, would do the same. We expected it to warm up. We expected its ancient frozen gases to sublimate to vent dust and ice into space, to grow a magnificent glowing coma and tail that would stream behind it. The Tianwen-1 images were clear. There was no tail. There was no coma. There was no gas. There was no dust. The images showed a single sharp point of light, a cold, inert and utterly silent object. It was not a dirty snowball. It was not an active comet. It was simply a rock. A dark, ancient, city-sized rock that had travelled for millions, perhaps billions of years from a star we will never know. It was passing through our home, a silent messenger from an unknown land. This single observation, this shocking absence of a tail, turned all our assumptions upside down. The questions only multiplied. If it wasn't a comet, what was it? An asteroid? But we had never seen an interstellar asteroid before. Why was it so dark, and what story was it carrying? The Tianwen-1 mission, in one brilliant improvised stroke, had solved the question of what 3i Atlas looked like, and in doing so had opened up a mystery far deeper and more profound than any of us could have imagined. The story of Comet 3i Atlas now shifts from one of bright anticipation to one of deep cosmic mystery. We are no longer just spectators. We have become detectives. The universe, it seems, had presented us with a puzzle, a paradox so confounding that it challenged our most basic understanding of these celestial travellers. This is the chapter of The Missing Tale, a cosmic ghost story where the evidence simply did not add up. To understand the mystery, we must first remember the physics, the beautiful and predictable science of what a comet is. Think of it as we have before a mountain of ice and dust, ancient and pristine, drifting in the unimaginable cold of deep space for billions of years. It is a time capsule. But when its long elliptical orbit brings it close to our star, everything changes. The sun's warmth, its relentless radiation, begins to touch that frozen surface. The ice does not melt. In the vacuum of space, it turns directly into a gas, a process called sublimation. This gas, carrying with it dust and grit, erupts from the comet's nucleus and forms a vast glowing cloud around it. We call this cloud the coma. This is the comet's atmosphere. But the sun's influence doesn't stop there. The sun also releases a constant high-speed stream of charged particles known as the solar wind. This wind, blowing outward at 1,000,000 miles per hour, quite literally pushes the gas and dust away from the comet. This is what creates the tail. In fact, there are usually two tails, a blue glowing ion tail made of gas pushed straight back from the sun, and a brighter, wider, gently curved dust tail which follows the comet's orbit. This is the signature of a healthy, active comet. It is a spectacular, predictable, and well-understood process. This is what we all expected to see from 3i Atlas. The first clue that something was different, something strange, did not come from a visual photograph. It came from mathematics. Scientists at NASA's Jet Propulsion Laboratory, or JPL, were tracking the comet's path with incredible precision. They used the laws of gravity, the pull of the sun and the planets to create a precise timetable, a map of where the comet should be at any given moment. But their calculations were wrong. The comet was not where it was supposed to be. It was slightly off course. It was moving in a way that the pull of the sun's gravity alone could not explain. It was as if another invisible force was acting on it. This is a known phenomenon, something astronomers call non-gravitational acceleration. It is not magic, it is the comet. The gas erupting from the comet's surface, the sublimation we spoke of, does not always happen evenly. If the comet is spinning, and a particularly active spot faces one direction, the gas shoots out like a jet. It becomes a tiny natural rocket engine. This gentle, persistent push applied over weeks and months is enough to alter the comet's path. The JPL data showed that 3I Atlas was definitely pushing itself. This was at first incredibly exciting. It meant the comet was not just active, it was hyperactive. It was furiously blasting its own substance into space, acting like a powerful rocket. This discovery immediately led to a new question: just how powerful was this rocket? The scientists could measure the deviation in its orbit and calculate the exact force required to cause it. And when they did the math, the numbers were staggering. The calculations showed that for Comet 3I Atlas to be pushing itself that hard, it must be losing a truly catastrophic amount of its own mass. The jets of gas had to be so powerful that the comet was estimated to have lost at least 13% of its entire mass during this period. 13%. For a celestial body thought to be several kilometers wide, this is not a gentle fizz. It is a violent, self-destructive explosion. The number they calculated was almost beyond comprehension: 4 billion tons. Let that number settle in your mind. 4 billion tons of ice and rock vaporized and blasted into the solar system. This was the minimum amount of material required to explain the comet's strange acceleration. This single calculation painted a vivid picture. This comet must be a raging inferno putting on a show of unparalleled violence. With 4 billion tons of material being ejected, the resulting coma and tail should be magnificent. It should be one of the brightest objects in the night sky, a glorious banner of gas and dust stretching for millions of miles. The evidence from the laws of physics was clear. 3I Atlas was giving its all in a final spectacular performance, and so every telescope on Earth, both professional and amateur, turned to watch the show, especially as the comet passed its closest point to the Sun, its perihelion. This is when the activity should be at its absolute peak. The Virtual Telescope Project, an international collaboration, pointed its robotic eyes. The Arnaves Observatory in Spain focused its mirrors ready to capture the glorious aftermath. And they saw nothing. Well, not nothing, but what they saw was not the triumphant raging comet the data had promised. Where there should have been a brilliant, spectacular tail, there was only a ghost. The images returned were shocking in their emptiness. They showed a faint, fuzzy, indistinct ball of light. The coma was there, but it was weak, diffuse, and tragically alone. There was no tail, no bright streamer of gas, no glittering fan of dust. There was just a sad, lonely smudge, a pale spectre of the object it was supposed to be. This was the central paradox. The data from JPL proved with cold hard mathematics that the comet was blasting 4 billion tons of material into space. But the photographs, the visual evidence from our best telescopes, showed that this material was nowhere to be found. How could we be sure the telescopes were working? What if the conditions were just poor? The universe, helpful as always, provided a perfect control subject. Just 2 days before the disappointing images of 3I Atlas, those same observatories had taken pictures of another comet named Comet Lemon. The images of Comet Lemon were perfect. They were a textbook example of a healthy, happy comet. They showed a bright, condensed nucleus, a strong, vibrant coma, and a beautiful, clearly defined classic tail stretching away from it. Comet Lemon was the before picture. 3I Atlas was the after. The comparison was damning. The equipment was working perfectly. The sky was clear. Comet Lemon proved that, but 3I Atlas, the comet that was supposed to be the show of a lifetime, was a profound exception. We were left with an impossible riddle. How can a comet push itself with the force of 4 billion tons of rocket fuel yet produce no visible tail? Where did all that material go? The data showed a raging fire. The photographs showed a dying ember. The numbers and the pictures were telling two completely different stories. What astronomers would soon discover is that both stories were true. The comet wasn't just active, it was coming apart at the seams. When we are faced with a mystery, our first instinct is to find the simple, comfortable explanation. And for this object there are many. Perhaps the skeptics say it was all just gas, a cloud of gas we didn't see which would explain the strange push. Or maybe our viewing angle was just wrong, a trick of perspective that made it look like it was doing something impossible. Or maybe simplest of all, our calculations were just off, a misplaced decimal point, a mistaken assumption. And these are all fair. In science, the most boring answer is often the correct one. But there is a principle Occam's razor which states the simplest explanation is usually the best. Simplest means the one that requires the fewest new assumptions. This is where the comfortable explanations begin to fail. To explain this one object, you can't just pick one excuse, you have to pick 10. You have to believe that 10 different unrelated, highly improbable things all happen to occur at the same time in the same place. It is like finding a single random coin on the sidewalk, but the coin is from the 16th century and it's balanced perfectly on its edge, and it is also humming a tune. At some point you have to stop calling it a coin and start asking what it really is. Let's begin with its path. The solar system is not flat, not really. It is a vast three-dimensional space, and an object from another star, a true interstellar wanderer, should respect that. It should come in from any angle from above or below on a path that is uniquely its own. But this object did not. It arrived on a trajectory that was almost perfectly aligned with the highway that our planet uses, the ecliptic plane. It was off by less than 5 degrees. Imagine a message in a bottle thrown into the ocean from a different continent, and it washes up, perfectly parallel to the main street of your coastal town. The probability of this happening by pure chance is just 1 in 500. 0.2%, it is suspiciously neat, and then it began to move in ways it shouldn't. As it neared the sun, it vented material. This is what comets do. The sun's heat turns their ice into gas, and this jet of gas pushes them. But the push is always away from the sun. The sun's light and heat, the solar wind, is a relentless force. It pushes everything. But we watched this object and we saw a force pushing it back toward the sun. Material was being ejected against the stream, fighting the sun's own pressure. This wasn't an illusion. It was not the optical trick we sometimes call an anti-tail. This was a real physical jet of matter, behaving in a way that defies the fundamental rules of solar physics. What force could possibly do that? Let's also talk about Oumuamua, that first famous interstellar visitor. It was a fascinating, tumbling, cigar-shaped object, perhaps the size of a city block. But this new object was a monster. We calculated its mass. It was 1 million times bigger than Oumuamua, and it was moving faster. In the cosmos, you can find very large things, and you can find very fast things, but it is exceptionally rare to find both at once. The universe tends to segregate these properties. To find an object that is both this massive and this fast, the probability of that combination is less than 1/10 of 1%. It is like discovering a blue whale that swims at the speed of a cheetah. The very combination of its properties is an anomaly in itself. But perhaps the most unsettling anomaly is the path it took. The timing. It did not just fly by, it took what can only be described as a tour. Its trajectory took it past Mars, it swung by Venus, it looped near Jupiter, and in a stunning series of coincidences when it passed these worlds, we had our own spacecraft there, probes and orbiters watching. It performed for our robotic eyes. And then the strangest part of all. As it made its closest approach to the sun, the point called perihelion, the moment it would be at its brightest, the moment every telescope on Earth would be pointed at it, it was perfectly hidden. Its path aligned precisely with the sun's glare, making it completely invisible from our home planet. It showed itself to our machines, and then at the critical moment it hid from its creators. The statistical chance of a random trajectory doing this, visiting our key planets yet perfectly shielding itself from Earth, is 0.05%. 0.005%. This feels less like a random orbit, and more like choreography. So we looked closer. What is this thing made of? We analysed its chemical signature as the sun cooked it. The results were wrong. We found more nickel than iron. In nature, in asteroids, in planets, iron is almost always the more abundant metal. But in our own world, in our own technology, we create alloys, industrial alloys specifically with high nickel content for strength and resistance to heat. And the ratios, the amount of nickel compared to the amount of cyanide, was higher than every single comet in our extensive databases. The chance of nature forging this specific metallic recipe so low in iron and so high in nickel, less than 1%. It looked less like something born from a cloud of dust and more like something manufactured. And the contradictions kept piling up. We call comets dirty snowballs. It is their defining feature. They are meant to be 70, perhaps 80% water ice. That is what boils and creates the magnificent tail. But when we measured this object, it was dry. It was a rock, only 4% water. This was not a snowball. This was a mountain of strange nickel-rich rock moving at impossible speeds. If it wasn't a snowball, then why was it behaving like one with jets and plumes, albeit jets that pointed the wrong way? There is a subtle property of light called polarization. It is simply the direction that light vibrates after it bounces off a surface. Every surface has a signature. Dust, ice, rock, they all scatter light in predictable ways that we can model. This object did not. The way it reflected sunlight was, in the words of one of the scientists, completely off the chart. It showed what is called extreme negative polarization. It did not match any model of natural dust. It did not match any known asteroid. It did not match anything. The probability of finding a natural surface that reflects light in this specific bizarre way, again, less than 1%. It's very probable skin is made of something we do not understand and have never seen before. And now we must look back, not at the object, but at the place it came from, that small patch of sky in the constellation Sagittarius. And when we do, a profound cold sets in, because we have stared at that exact spot for a long time. In the year 1787, a radio telescope in Ohio was listening to that region of space, and it picked up a signal so strong, so clear, so perfectly structured there, that the astronomer on duty, Jerry Eman, could only circle the data on the printout and write one single word in the margin: wow, the wow signal. 72 seconds of a perfect narrowband radio transmission that looked exactly like what we imagined an intelligent interstellar broadcast would be. And then it was gone. We have pointed our most powerful telescopes at that spot for decades and heard nothing but sounds, until now. Now from that exact same patch of sky, within 9 degrees of the origin of that mysterious signal, this object arrives. The odds of these two unique, profound, unexplained events, the greatest SETI mystery of the 20th century and the greatest interstellar mystery of the 21st, coming from the same place, is 0.6%. A coincidence? It must be a coincidence. As it flew, it continued to defy our models. It brightened, but it brightened faster than any other comet in our entire database. Its activity ramped up with a speed that our models could not explain, and its colour. Comets and asteroids are usually reddish, the colour of simple organic dust. This object was blue, a distinct, unusual blue. It was bluer than our own sun. This is extraordinarily rare, so it is also the fastest brightening, and one of the bluest objects we have ever seen. Add it to the list. We come now to the final and perhaps the grandest mystery, the summary of all its actions. We saw the jets, we measured the brightness, we calculated the mass it was losing, and the math tells us, as it flew through our solar system, this object ejected 4 billion tons of material. 4 billion tons, an unimaginable cloud of dust and gas pushed out by forces we don't understand. A tale that should have been magnificent, a tale that should have been obvious, unmistakable, trailing behind it like a scar in the sky. So where is it? Where did it go? We have looked, we cannot find it. That much material, 4 billion tons, does not just vanish. It should be trailing behind it, a glittering highway of debris. But there is nothing. It is as if it shed this material and then the material itself had disappeared. It is the final silent screaming contradiction. And so we are left here in the quiet with this list. A list of 10 impossibilities. Any one of these, a single anomaly, would be the subject of scientific papers for a decade. A fascinating puzzle. Any two, a deep, profound mystery. But the 10 anomalies, each one with a probability of 1% or 0.1% or even less. When you multiply those odds together, you get a number so small it is meaningless. The coincidence explanation, the it's just a rock explanation, requires us to believe in a miracle. It requires us to believe that the universe just happened to send us in one single package the rarest and most contradictory object ever conceived. An object that aligned with our planets, that fired jets the wrong way, that was made of industrial metal that had no water, that reflected light in a way physics cannot explain, that came from the origin of our most famous alien signal, and that somehow hid 4 billion tons of its own tail. Or there is the other explanation, the one that is not so simple, the one that is perhaps not natural, an explanation that suggests this was not a visit, but a message, or a vehicle. And that thought, that is the one to hold as you contemplate the vast, dark and silent sky, and drift to Slee. We have followed the trail of clues one by one, each one a deviation from the expected, each one a question mark placed against our tidy models of the cosmos. We have seen the strange orbit, the unusual shape, the unexpected reflectivity. We have noted the absence of a coma, the lack of water, the peculiar tumble. and we have measured the final definitive anomaly, the push. The gentle unseen hand guiding this visitor away from our sun faster than gravity alone could explain. We have gathered these 10 anomalies, these 10 strange facts, and held them up to the light. Individually, perhaps we could explain them away. Science is good at that, but now we arrive at the most difficult part, the part that keeps astronomers awake at night, the part that takes this story from a simple curiosity to a profound and perhaps uncomfortable puzzle. The true problem is not any single anomaly, it is all of them, together, at the same time. The strangeness is not additive, it is multiplicative. Each oddity multiplies the improbability of the next. It is one thing to find a needle in a haystack, it is another thing entirely to find a needle that is also bright blue and warm to the touch and humming a low, steady note. You can no longer just call it a needle, it has become something else. When you sit down to do the math, when you try to calculate the odds of a single natural object possessing all 10 of these characteristics, the number becomes vanishingly small. The probability plunges. We are forced to say that if this object was natural, it was a 1 in a 10,000 occurrence. And many scientists looking at the same data would say that number is far, far too generous. They would say the odds are 1 in a million or 1 in a billion. This is the statistical heart of the dilemma. When does an anomaly stop being just an anomaly and start being a message? When does a collection of stunning coincidences stop being coincidence at all and start being a signature? This is not a small discrepancy, it is a chasm. It is the feeling of finding a perfectly carved, polished wooden boat washed up on the barren, treeless shore of a remote volcanic island. You can insist and insist and insist that the boat must have been formed by lava flows, that it is just a very strange-looking rock. Or you can begin to consider the only other possibility, that it came from somewhere else. This is the crossroads, and here we find two distinct paths. Hypothesis A, the conventional view. The first path is the path of caution. It is the safe path. It is the path that science by its very nature must prefer. This is Hypothesis A, the conventional. This hypothesis states with firm conviction that the object was entirely natural. It was a piece of another solar system, a shard of a planet, a fragment of an ancient comet, sent tumbling through the void for millions of years only to intersect with our own small system by pure chance. But how then does it explain the 10 anomalies? It explains them as an extreme statistical outlier, a fluke of cosmic proportions. This hypothesis is strong because it is humble. It admits our profound ignorance. It says, the cosmos is infinitely stranger than we imagine, and our first few glimpses are bound to be confusing. After all, what is our sample size? We have only just begun to look for these interstellar visitors. At the time this object was seen, our sample size was 1. It was the first. Now our sample size is 3. Just 3. What can you truly know from only 3 examples? It is like pulling 3 random pebbles from all the oceans of the world and then trying to write the definitive history of geology. It is simply not enough data. So Hypothesis A argues that we just happen to see the weirdest one first. The 1 in a million shot, the statistical ghost. It is possible. In a cosmos with hundreds of billions of galaxies, each with hundreds of billions of stars, the 1 in a million event is not just possible, it is guaranteed. It happens every single day somewhere. We just happen to be the ones to see it. This hypothesis requires no grand new assumptions about the universe. It does not require us to invent new physics. It just requires us to accept that we were witness to an extraordinary but entirely natural event. Perhaps in other solar systems under red dwarf stars processes, we cannot imagine create objects like this. Hydrogen icebergs, or nitrogen shards, or cosmic dust bunnies, solid light and fluffy pushed by the sun. We have never seen such things, but that does not mean they do not exist. This is the argument from humility. It is powerful, and for most working scientists it is the most sensible, the most rational, and the most likely explanation. Hypothesis B, the unconventional view, but there is another path, a path that is less travelled, a path that leads to a place of profound and deeply uncomfortable wonder. This counter-argument is championed by scientists like Avi Loeb, and his position is often and perhaps purposefully misunderstood. It is not, as many critics claim, a sensationalist leap to a wild conclusion. It is not a desire for headlines. It is in its purest form a rigid adherence to the scientific method. Loeb's position is simple. What does the data say? We must follow the data even if it leads us to a place we did not expect. The purpose of science is not to find the answer that makes us feel comfortable, It is to find the answer that fits the facts. And the data he points out simply does not fit our natural models. Not well. We have to invent new unseen, unproven categories of natural objects, these nitrogen icebergs, these hydrogen comets, just to make the natural explanation work. Loeb's question is this: why are we so willing to invent entirely new categories of natural things that we have never seen, yet so utterly unwilling to even consider the one unconventional hypothesis that might explain everything using technology we know is possible? This brings us to hypothesis B, the unconventional, the challenging. The hypothesis that if true changes our place in the cosmos forever. Hypothesis B states quite simply that this object was not entirely natural, that it bears the mark of design, of engineering, of purpose. This is not a statement of fact. This is not proof. It is an idea. It is a lens. It is a key offered to see if it will perhaps unlock the puzzle. What happens if we dare to try this key? What happens if we look at the 10 anomalies, not as a random collection of cosmic weirdness, but as a set of design features? Suddenly, the pieces which felt so jagged and random begin to snap together. The noise begins to sound like a signal. The carved boat on the volcanic shore suddenly makes sense. Reinterpreting the anomalies. Let us walk back through the clues one last time, but we will wear this new lens. First, the orbit. It came from a special place, the local standard of rest. This is the average motion of all the stars in our galactic neighbourhood. It was in a very real sense, parked in the galaxy, floating with the current until it just happened to drift into our system. Is that a coincidence, or is that the perfect orbit for a network of probes? Boy, a listening post floating in the galactic stream designed to wait patiently until it encounters a new star system. It wasn't aimed at us, it was just waiting. Second, the composition. The object reflected light like something metallic. The user's notes suggest a possible nickel alloy. Why is that important? Think of what we use to build our most advanced technology. Our deep space probes, our satellites, our jet engines. We use high-performance alloys, mixtures of metals designed for specific tasks. We use nickel for its incredible strength, its resistance to corrosion, its ability to withstand terrifying heat and bone-chilling cold. It is quite literally a space-age material. A comet is a lump of dirty ice. An asteroid is a chunk of rubble. A machine is crafted from a resilient, functional alloy. The data pointed, however weakly, toward the latter. Third, the lack of water. This was one of the greatest shocks. It was not a comet. It did not outgas. It did not shed water vapor as it neared our sun. We are obsessed with water because for us water means life. But for technology, for a machine, water is a problem. It freezes, it expands, it cracks things. It turns to steam. It is volatile. If you are building something to last, to cross the interstellar void for 1,000,000 years, you build it dry. You make it from rock and metal. You make it stable. The object's dryness was a deep puzzle for astronomy, but for an engineer it would be requirement number 1. Fourth, the push. This is the core of it all. The non-gravitational acceleration, the gentle, smooth, continuous thrust away from the sun. A force that was not explosive, not random, but constant, and it got weaker as the object got further from the sun. This is the exact, precise, unmistakable signature of sunlight. Light itself is made of photons. These tiny packets of energy have no mass, but they have momentum. When they strike a surface, they push. A solar sail is just a very big, very light, very reflective mirror. It is a technology that we right now are actively trying to perfect. We know it works. It requires no exotic fuel. It needs no heavy engine. It just needs a star. This object's strange, flat, tumbling shape, its high reflectivity, and its mysterious acceleration are all explained perfectly and simply by a light sail. A sail unfurled catching the photons of our sun to push itself onward. The natural explanation, a jet of invisible gas, explains only the push, but it completely fails to explain why the gas was invisible. Which brings us to the final clue, the missing tail. If it was a comet, where was the debris? The powerful Spitzer space telescope stared at the object's path. It looked for any heat signature, any carbon-based gas, any dust, anything at all. It found nothing. The void was clean. This is the single most damning piece of evidence against the comet theory. But for hypothesis B, it is not a problem at all. A light sail has no tail, it has no exhaust. Its fuel is light itself. Or, as the user's note suggests, perhaps it was an engine. but not a crude, messy one, a hyper-efficient one whose exhaust was not dust but perhaps pure ions, or something we cannot detect. The material wasn't debris that vanished, it was propulsion that left no trace. So where does this leave us floating in the quiet darkness? We are left with two stories, and both of them are incredible. Story A. We were visited by a 1 in a billion natural object, a statistical ghost that breaks all known categories of astronomy and requires us to invent new unproven theories to explain it. Story B. We were visited by a piece of technology, a probe, a relic, a sail, sent by someone or something else. We must be very, very clear. Hypothesis B is not proven. We have no definitive proof. We have no photograph of a metallic ship. We received no radio signal. All we have is a trail of clues, a collection of anomalies that all point in the same uncomfortable and fantastic direction. But the question, the hypothesis, should not be dismissed. To reject it out of hand, to call it unscientific simply because it makes us uncomfortable, is perhaps the most unscientific act of all. It is an act of closing our minds. It is an act of human arrogance, an assumption that we are the only minds in this vast cosmos capable of thought, of engineering, of building. This silent visitor, whatever it was, has moved on. It is back in the cold, dark void, speeding away from us. But it left its question hanging in the interstellar air, a cosmic riddle. And perhaps the search for that answer, the willingness to even ask it, is what will in the end help us grow as we continue our own journey, looking for our own place among the stars. In all our journeys through the cosmos, in all our talk of stars and planets and the grand sweep of time, we have been collecting facts. We have been gathering what we know. But perhaps the greatest gift the universe gives us is not the answers, it is the questions. It is the profound, humbling and sometimes frightening experience of not knowing. This is the very essence of science. It is not a book of facts closed and finished. It is a process. It is a way of walking into the dark holding only the small candle of our curiosity and being honest about what we see and what we do not. Right now in our real time, astronomers are facing such a moment of profound humility. They are looking at data that is, to be blunt, truly strange. There is an object that has passed through our solar system. We call it 3I Atlas. The eye tells us it is interstellar, a visitor from the vast emptiness between the stars. It is the third such object we have ever confirmed, and it is baffling. It is not behaving quite like a comet. It is not behaving quite like an asteroid. Its path, its brightness, its signature, they are ambiguous. They do not fit neatly into the boxes we have built. This is where intellectual honesty becomes the most important tool we have. It is the courage to look at the data and say, we do not understand this. It is the discipline to resist the temptation to invent a fantasy, and instead to simply sit with the mystery. We must accept what the universe is telling us, not what we want it to tell us. This object, this traveller, is a message from the deep, and the message may simply be you know less than you think. But this lesson comes with a deadline. Our time to even ask questions of this visitor is running out. 3. I-Atlas is leaving us. It is on its way out, falling back into the interstellar night from which it came. It is already faint a ghost in our most powerful telescopes. Our last real chance to observe it, to gather the last photons of light from its surface, will be this December. As 2025 comes to a close, so does our window. By January of 2026 it will be gone. It will fade to a point of light so distant, so weak that it will be lost to us forever. Think of that. A mystery from another star system, a piece of another world, is right here in our cosmic backyard. And we have only a few short weeks left to say goodbye, to ask our final questions before it vanishes, taking its secrets with it. Does this frantic scramble for data, this last-ditch effort to understand, even matter? It is just one strange rock, or is it? I'm reminded of a story, a small email that a senior astronomer received a few years ago. It came from a high school student in Chile, a young man named Dario Villan. He lived in a small town not far from the giant observatories that sit high in the Atacama Desert. He had been reading about the mysteries of the universe, and he had a question. It was not a question that would win him a Nobel Prize. It was a simple, honest question about why a certain star behaved the way it did. The astronomer, busy with research and deadlines, almost deleted it. But he paused. He read the question again, and he was struck by its clarity. It was the kind of fundamental question that professionals sometimes forget to ask, because they are so busy with the complex details. The astronomer wrote back, and it started a conversation. That young man, Dario, is now a university student studying physics. This is the true value of the question. This is the legacy of objects like 3I Atlas. The data we collect in December might not solve the mystery. We may never know what it was, but the story of it, the puzzle of it, will be told to students for decades, and it will inspire the next generation. Somewhere another Dario villain is looking up, wondering about this strange visitor, and that wonder is the spark that will light the future of discovery. The purpose of science is not just to find truth, but to inspire the search for it. This brings us to the deepest question of all. How do we as a species approach the unknown? When faced with something like 3i Atlas, a puzzle with a ticking clock, what is the right path? The answer is humility. The universe does not owe us explanations. We are the newcomers here, small beings on a tiny world awake for only a brief moment. Our journey is not one of conquest, but of perception. We are learning to see. And this is where we find the true soul of science. It exists in the space between what we know and what we don't know. There is a difference between truth and understanding. Truth is the observation. It is the data. We can say 3i Atlas is moving at this speed on this trajectory. That is a fact. That is truth. Understanding is the why. Why is it moving that way? Why did it come from that direction? Why does it exist? Science is the bridge we try to build between the what and the why, between observation and comprehension. Sometimes we can build that bridge quickly, but other times with mysteries like this one, we must simply stand on the shore of observation and look out at the great wide ocean of the why, and accept that we cannot cross it today. To be intellectually honest is to be comfortable in that space, to hold the strange data in our hands and to resist the urge to name it, to categorize it, to tame it. We will watch 3i Atlas fade. We will collect our last bits of light, and then we will be left perhaps not with an answer, but with a better, deeper question. And that in itself is a precious gift. It is the universe teaching us to be humble. It is the cosmos whispering to us, be patient, keep watching. There is so much more to see. That single image captured by the Tianwen-1 orbiter as it journeyed towards Mars will be studied for generations. Long after we are gone, scientists and philosophers will still gaze at those few faint pixels of light, debating what they represent. It is a turning point in our history, a photograph of something that does not belong to us, something that was just passing through. For the entire history of our species, we have lived under a sky that we believed was essentially ours. The comets, the asteroids, the planets, they were all part of our local family, born from the same cloud of gas and dust as our Earth. And now we know the truth. The space between the stars is not an empty, sterile void. It is a highway, and we are just beginning to see the traffic. In the span of only a few short years, we went from 0 confirmed visitors to 3. This object, this 3i Atlas, is only the third of what we now suspect is a constant flowing stream of objects drifting from one star system to the next. They are travelers on journeys that last millions, even billions of years. We just never had the tools to see them. Think of it. The first Oumuamua was a complete surprise. A tiny, fast-moving mystery that tumbled past us, accelerating in a way we still cannot fully explain. We saw it only as it was leaving. The second Borisov was a reassurance. It was a comet behaving exactly as a comet should, full of water and chemicals we recognized. It told us that other solar systems are built from the same ingredients as our own. And now this third one, 3i Atlas, a deep, complex puzzle with its 10 anomalies, its strange silence, its sudden and violent end. This is not a trickle. This is the opening of a floodgate. And soon our view of this cosmic river is about to become infinitely clearer. On a mountaintop in Chile, a new magnificent eye is preparing to open. It is called the Vera Rubin Observatory. It is not like other telescopes that stare at one tiny patch of sky for a long time. This observatory is a sentinel. It is a vast, sweeping gaze. Its massive camera, the size of a small car, will scan the entire southern sky over and over every few nights. It will create a motion picture of the cosmos, capturing everything that moves, everything that changes, everything that flashes in the night. Astronomers predict that when this observatory begins its survey, we will go from finding one interstellar visitor every few years to finding one every year, or perhaps one every month. Imagine that, a steady catalogue and inventory of travelers. We will no longer be surprised. We will be waiting. We will see them coming from far away. We will have time to point our other telescopes, our space probes, and perhaps one day to send a mission to greet one. This is the true breathtaking promise of this new era. For all of human history, if we wanted to know what another star system was like, we had to dream of impossible ships. Ships that could travel near the speed of light, ships that would take thousands of years to cross the void. We thought trapped on our small blue island, only able to look, never to touch. But we were wrong. We do not have to go to them. They are coming to us. Each of these objects, Oumuamua Borisov Atlas is a free sample, a piece of another world delivered to our doorstep free of charge. They are time capsules. They carry the chemical fingerprints of the star systems they were born in. They are fragments of ancient planets, or perhaps the icy leftovers from the birth of a distant alien world cast out into the dark. By studying their light, their composition, their ice, and their rock, we are doing interstellar science without ever leaving home. We are learning what other solar systems are made of. We are discovering if the building blocks for life are common or if they are rare. Each one is a message in a bottle tossed into the cosmic ocean billions of years ago, and we are at last standing on the shore beginning to read them. And what have these first 3 bottles told us? The first one. Oumuamua told us that the universe is stranger than we imagined. It was an anomaly. It left us with far more questions than answers, a riddle that still haunts us. The second comet Borisov told us that the universe is familiar. It was a comfort. It proved that the laws of chemistry and physics that build our solar system are at work everywhere. It was a sign of unity. And the third, an atlas. It told us that we know nothing at all. It was neither a simple riddle nor a simple comfort. It was a paradox. It was a collection of mysteries that seemed to contradict each other. It arrived like a comet, but died like an asteroid. It was bright, then faint. It was there, and then it was gone. 3 visitors. The first was strange, the second was normal. The third was something else entirely, something complex and deeply puzzling. This is the dawn of interstellar astronomy, and the only thing we know for certain is that the universe is far more creative and far more wondrous than we ever dared to believe. As you drift now, as you let the weight of the day dissolve, let this new awareness settle over you. We are not static, we are not isolated, we are part of a grand flowing cosmic ecosystem. The space above you, which seems so dark and still, is alive with motion. Silent voyagers, fragments of other worlds, are sailing past us right now in the quiet of the night. We are just beginning to wake up to their presence. There is no need to solve these mysteries tonight. The puzzles are not for you to carry, they are a lullaby. A reminder that the cosmos is vast and full of wonder. A promise that there is always more to discover, always more to dream about. Let the questions guide you. Let the strangeness of Oumuamua and the paradox of Atlas simply be. They are part of the great peaceful unfolding story of the night. And as you sleep, you can rest. Rest in the knowledge that while we are here dreaming in our small quiet corner of the galaxy, the universe is busy, sending us new wonders, new mysteries to greet us in the morning. Sleep now, rest, and dream of the voyagers, sailing silently through the endless, peaceful and beautiful night. And so we arrive at the end of this particular path. We have journeyed with a strange visitor, turning it over and over in our minds, examining it through the cold, clear lens of mathematics and the warm, hopeful filter of our imagination. We have looked at the data, we have weighed the evidence, and we find ourselves standing at the edge of a great mystery. But this final part of our journey is not about the object itself. It is about what the object leaves behind here with us. It is about the questions that echo in its wake. Hiding just beneath the surface of every chart, every calculation, and every debate about 3i Atlas, there is one question. It is the question that drives our telescopes to scan the night sky. It is the question that we whisper almost unconsciously when we look up at the silent stars. Are we alone? This single profound question is the true engine of this entire story. This object, whether it is a dead piece of rock or something more, is the first visitor we have ever confirmed from another solar system. It is a messenger from the deep. A bottle washed ashore from an ocean we have only just begun to realize exists. And because it is the first, it forces us to confront this question not as a fantasy, but as a practical scientific possibility. Every argument for its strangeness is an argument, however quiet, for maybe not. And every argument for its natural origin is a defense of the profound and perhaps terrifying idea that maybe some. This is the great challenge of sorting the signal from the noise. Science is the patient art of listening to the universe, of trying to find a meaningful pattern in an ocean of static. We are tuned to expect the static. We are trained to believe that the universe is full of random natural process. And then, this visitor appears. It doesn't just present one puzzle, it presents a collection of them. The user's outline mentioned 10 anomalies. 10 strange behaviors that, when taken together, paint a confusing picture. One anomaly can be dismissed as an error in measurement. 2 can be a coincidence, but 10 does a collection of coincidences all pointing away from the normal will eventually become a signal. This is the heart of the debate. At what point do we stop trying to force the data to fit our old models and begin to wonder if we need a new one. This object presents us with a set of facts, its shape, its acceleration, its path, that are difficult to explain all at once. Is this just the noise of a chaotic cosmos? Or is this a faint, clear note, a signal that we are not the only ones to have ever built something? We do not have the answer. But for the first time, we have the data to seriously ask the question. In this we find the true gift of 3i Atlas. Perhaps we are not meant to solve its mystery, not yet. Perhaps its purpose was not to be an answer, but to be a lesson. We must be intellectually ready for the day we find something that is unambiguously artificial. We cannot be caught by surprise. This object and the fierce debate it created is our training. It is our rehearsal. It is the universe giving us a practice test for the most important discovery in human history. It is forcing us to build the tools, the arguments, and the intellectual humility needed to face such a revelation. We are learning how to have this conversation. We are learning how to separate belief from evidence. We are learning how to disagree, how to test, and how to stay rational in the face of the extraordinary. Because of this strange visitor, we are now better prepared for the next one. We are training our scientists, our systems, and our collective imagination to be ready. And that is why this object's legacy is secure. 3i Atlas will be a case study in textbooks for 100 years. Its story is not over simply because it has left our skies. The data we gathered, every photon of light, every measurement of its position, is now preserved. It sits in digital vaults waiting. Decades from now, a scientist who has not yet even been born will open this file. She will have new tools, new theories, and new forms of artificial intelligence to help her. She will reanalyze this data. What will she see? Will she see the quiet natural comet that many see today? Or will she find the one crucial detail, the one piece of the puzzle we missed that changes the story forever? This object no longer belongs to us, the people who saw it pass. It now belongs to history. As we let our minds drift, let us hold on to one final haunting image. It is the image at the center of the mystery as described in the notes for this journey. A traveler arrives from the void. It sweeps past our sun, warmed by a star that is not its own. And as it does, something happens then. It changes. It loses mass. A significant amount. The notes suggested 13% of its entire being just vanishes. A piece of it is given to our solar system, and yet it leaves no trace. There is no cloud of dust, there is no tail of gas, there is no debris field. An object cannot simply lose 13% of itself and leave nothing behind. It is a ghost story told in physics. It is a paradox. An object that was here, that changed while it was here, and that left as if it had never been. A visitor that came, lost a piece of itself, and then vanished into the forward dark, leaving only questions. In the end, this is where we must leave it. We are a young species standing in the darkness, pointing our small lights at the vastness. The universe does not have an obligation to answer us. It does not have to make sense. The value is not in finding the final answer. The value is in the questions themselves. The value is in the journey of looking. The act of observation, of wondering, of reaching out with our minds is what gives us our place in the cosmos. We are the part of the universe that is trying to understand the rest. We will continue to watch. We will continue to listen. The sky is not empty. It is just very, very large. And we are ready for the next guest.